In this video, I'm going to cover how we graph trig functions and some properties of these graphs. So first, just a quick reminder about the unit circle. We know that for any point x, y on the unit circle, x is cosine of theta and y is sine of theta, where theta is the angle between the positive x-axis and the radius between the origin and that point. So for example, if we're looking at the point 0, -1, our theta value is 3 pi over 2. And cosine of 3 pi over 2 is 0, and sine of 3 pi over 2 is -1, since we're at the point 0, -1. Okay, so now we're going to graph sine. Well, I put some values in a table on the right-hand side. I'm going to start off with just the values that we actually have as, and I'm going to start with the values that we have indicated on our graph on the left-hand side. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, we know that sine of 0 is 0, sine of pi over 2 is 1, sine of pi is again 0, sine of 3 pi over 2 is -1, and sine of 2 pi is 0. And if you're a little confused about how we found these values, go back and watch the unit circle video. Well, now for the other values, we know that sine of pi over 4 is square root 2 over 2, sine of 3 pi over 4 is also square root 2 over 2, and sine of 5 pi over 4 and 7 pi over 4 are both negative square root 2 over 2. So now we're starting to see roughly what our graph looks like. Now remember that since we're dealing with the unit circle, our values of theta only range between 0 and 2 pi, and in fact, sine of 0 equals sine of 2 pi, since we're back at that same point again. So what that's telling us is that the values of sine after they reach 2 pi just start repeating themselves again. So basically, if we can figure out what the graph of sine looks like between 0 and 2 pi, then we can just repeat that same portion over and over again. So the graph of sine between 0 and 2 pi will look identical to the graph of sine between 2 pi and 4 pi, between 4 pi and 6 pi, and so on. So now just basically connecting the dots here to draw our function, we end up with something that looks like this. So we have our sine function, and if we wanted to do the same thing for cosine, we would get another graph that looks like this. And you can see that the graphs of sine and cosine are very similar. Cosine is just the sine function shifted over a little bit, which makes sense if we remember that the values we got for cosine were the same values that we got for sine, just often for different values of theta. So, for example, sine of 0 was 0, while it was cosine of pi over 2 that was 0. Now for tangent, it's a little more complicated. Just a quick reminder, we know that tangent is sine divided by cosine. So anytime that cosine is 0, our tangent function does not exist. So in particular, we know that cosine is 0 when we're talking about theta equals pi over 2 and theta equals 3 pi over 2. So our tangent function doesn't actually exist at these values. You can see as it gets close to these values, our function approaches infinity or negative infinity, but we never actually input pi over 2 or 3 pi over 2 into our function.